Welcome back, everybody. I want to go over just two examples of graphing a quadratic function from vertex form. I want to show you what I want you to record, and I'm going to give you one example to try on your own and bring to class tomorrow. Tomorrow in class, we're also going to add a couple of other notes to these graphs. So there's a few other points on this graph that I want to identify, and a couple other things I want to label. But for today, I just want to make sure that we all understand, if I give you a function in vertex form, how you graph it. So let's start with our first example. F of x equals -3 times the quantity x minus 1 squared plus 5. So the first thing I want to do is identify my a value, which is -3. And -3 is going to help me realize that this graph opens down because it's negative. The vertex, I'm always going to have you record the vertex. Even though it looks like x minus 1 in here, my vertex is really at +1, 5. And I also need my rate of change pattern in order to graph this function. So remember, your rate of change pattern follows that equation, 1a over 1, 3a over 1, 5a over 1. So if a is -3, I'm going to put that in here. 1 times -3 over 1 is -3 over 1. 3 times -3 over 1 is -9 over 1. 5 times -3 over 1 is -15 over 1. Even if you don't use all three rates of change, I still want you to record those on your paper whenever you graph. So in order to graph this function, I'm going to start by plotting the point 1, 5. That's my vertex. I know this graph opens down, so I'm going to follow the pattern, and I'm going to make sure that I start by going down 3 and out either side 1. If you have enough room on your paper to go down 9 and over 1, you certainly can. I don't think I have enough room, so this is all I'm going to do, but that's enough that I can connect these to make a nice smooth curve. So I'm going to try to make sure it goes through the points a little bit better than I did, but you get the general idea. Okay, make sure you extend your graph down far enough so that it covers most of your coordinate plane. Don't stop short at the 2 points that you found. So here's the function. F of x equals -3 times x minus 1 squared plus 5. So what I'm going to let you do on your paper is fill in the domain and range for both of these examples. So let's move on to the second example. So my second example is the equation y equals x plus 2 squared. So my a value, again, if you don't see anything out front, we're going to assume that a is 1. And because it's a +1, this graph is going to open up. My vertex, even though that's an x plus 2 inside, I know that my h value is really -2. And my k value out back, there's nothing there. So I'm going to assume that that's a 0. So my vertex here is at -2, 0. And my rate of change pattern, because a is 1, nothing changes about my rate of change pattern. So it's still 1 over 1, 3 over 1, 5 over 1. So I'm going to start by plotting the vertex at -2, 0. I'm going to use my rate of change pattern, and I'm going to make sure I go up because I know this graph opens up. So I'm going to go up 1 and out either direction 1. And I'm going to go up 3 and out 1. And I don't have enough room on my paper to go up 5 and over 1. If you do, that's great. If not, this is just enough points for us to connect. And end your graph with 2 arrows on either side. So what I would like you to try on that third graph on your paper is graph this function. Y equals 2 times the quantity x minus 4 squared plus 2. And I want you to find everything that I found, find your a value, your vertex, your rate of change pattern, and then also tell me what the domain and range is. Please bring these graphs to class tomorrow so we can talk a little bit more about each one. Also, feel free to write down any questions that you have or anything that you're still kind of confused on, and we'll make sure that we go over those tomorrow.